All right, I think that now we are ready. So thank you everyone for being here. For me it's very special to be in Portugal because I'm from Brazil. So if it wasn't Portugal, I would not be here today, I think. So my name is Caio Sacramento. I think that PJ could not say my last name. And I am from Brazil. I did my graduation and master in computer science there, but I live in San Francisco today, where I work since 2011 at Miden, which is a company that develops free software for cross-culture communication and translation and fact-checking. We have an office in Cairo, so I've been to Egypt. It's really beautiful. Hope I can be at RubyConf next year. On this talk, I'll be talking about our work to refactor our main software. It's called Check, which is a free software for social media fact-checking, which used to be a monolithic Drupal application, or in other words, a monster. And we refactored that using a backend on Rails and a front end using using Relay and React.js, and both are based on templates that we built and that we use on our other softwares. So for the backend, we have a Rails template called the Lapis, which we use on our other softwares as well. And for the client side, we have a human generator called the Kiefer, and we use it both to rebuild this application. So it will be like lightning talks about 4 different topics and all by myself, and how they are divided. So just to be clear, GraphQL and Rails on the back end and React and Relay on the front end. Let's start with GraphQL already. So what is that? It's a query language for your API, and lets you run queries against your backend using a type system. So it's like a way that you can declare your data model in a clear way and use that as also as an API to query that data. So let's compare it with REST, because this way it can be more clear. So here we have a typical image of our application. You have a social media and you have people saying things about this social media thing, trying to find out if it's true or not, or how true it is or not. So here we have an example. Someone filmed the Avengers in action, and then Captain America and the Iron Man can say, oh, this is true because we were there. And then Bruce Banner says, oh, I don't remember anything. Who is that green guy over there? For me, this is false. So let's use it in an example. So usually we have on our application, this is just a little piece of the data. We have a media item which can receive multiple tags, and it can also receive multiple comments by different users. So all the examples that I'm going to use during the presentation will be based on this little piece of the data model. So using REST in order to attend this interface in an ideal world, we would have beautiful API endpoints like this, where you can get a single media item and then the comments of that and then the tags. And you can see that in order to fulfill this interface, you'd have to make many different requests to your backend. And if you want to use less requests, what could you do? You could have like custom API endpoints like medias and comments, or pass a series of parameters to API endpoint to say that you want like a media object and also all the comments along with that. And you could see that in a short time your API would become another monster, just to fulfill all the crazy requirements of the design team. So too many requests or too much stuff. So GraphQL appears as an alternative that you can make your data available for the client. So you have only one API endpoint, which is usually at /GraphQL, but doesn't need to be, but it's always about convention over configuration. So you have just that API endpoint, which is a post endpoint, so we don't need to worry about the size of the query that you're sending to the server. And in order to request the data needed to fill our interface, how would we do this using GraphQL GraphQL. You would make a post request to the GraphQL endpoint, and the query parameter would be like this. So it's a structure that looks like JSON, but it's not really JSON. So here I'm saying that on the first level, I want to query the media item with ID 1, and from that item I want the attributes title and bed, and then a list of the first 3 tags, and from each tag I just want the tag value, and then I want also the first 5 comments, and from that comments I want the created data and text attributes, and also the user who posted the comments, and from that user I want the name and the avatar. So in a single query I can ask for all the data that I need for my interface. And when you compare the query that you send to the server with the data model that you are working with, you can see that's pretty readable and makes some sense. You can look at the query and you have quite an idea of what's the data that you are dealing with. And after you make that request, the return from the server, this time will be a real JSON structure with just the data that you asked for. So for each field name and for each attribute, you will have a key on the JSON that was returned by the server, keeping the same nested structure that you asked for. And all of this is done using a type system. So you can see here that for each field that I asked from the backend, I have it corresponds to a model of my data model. So here, the media field corresponds to the media model, the tags field corresponds to the tag model, and also keeping the structure of the relationships between them. So it's pretty clear. Again, that's all about convention. I could have a field called something, and it could return a media model, but we're trying to keep the convention here. And how to define each of those types. So at the first level, you have at the root something that we call the query type. And the query type, you define the things that can be requested at the very first level. I mean, that's not inside other types. So here, for example, I defined 4 of them. The first 3 can receive a parameter, and the last one doesn't. It could be, for example, an endpoint to receive the information about the current logged in user. And something that is very cool is that one field can have as a type another type, not only the primitives like string or number. So for example, here on the comment type, I have the user field which return an object of the user type which is defined just below. So you don't need to repeat yourself when dealing with other types. So how all of that's play with Rails? The Rails GraphQL gen makes your work a bit easier by providing auto-generated documentation, code generation for you, static validation, because the types are actually created when you start your server. So if there's any problem with that, it won't be, the application won't start. And you can use a cool UI to query your data model, which is called GraphQL. And then it makes things much easier than doing everything on hand. So you can, 2 ways to have a Rails API with GraphQL supports out of the box. As I said in the beginning, we have a Rails generator that we used, and that contains GraphQL support built in. So you just need to download it and create a new Rails application using that. And it is a headless API, so there is no view, no nothing. And it contains support to both REST and GraphQL, among other cool things. But if you already have a Rails application up and running, or you want to create it from scratch, it's very simple. It's literally just 3 steps in order to make your Rails API GraphQL ready. So you just need to add 2 gems to your gem file and have a controller with just 1 method, because, as I said before, there is only 1 API endpoint to handle all the requests. And then you just receive the query variables, pass it to the GraphQL class, and then return just the JSON that it's returned. And Then after you have set up your application, you just need to start creating your types. So I showed before how does a type look like in the GraphQL syntax here on the left, and then how to define it in Rails. So the library provides some definers for you, and then you just need to enter a few things. If you don't want to put much details about the field and you just define the name and the return type, it will assume that the model that this type is returning has that method defined. So here, if I define the title field, it's expected that the model instance has that method for me. But you can also have a custom behavior for some fields by just implementing this resolve method, which receives the instance of the object that you're dealing with plus a list of arguments and the current context. And so those two things were for fields that return just one object. If you want to return a collection of things, then that's something that's on GraphQL is called connection. So here I have a connection called comments, which receives an argument, and then I just return the list of comments associated with that media item over there. So everything we saw now was to retrieve data, okay? And now we are going to talk about how to perform changes to the system. So this is something that's in GraphQL is called a mutation. So mutations are requests, like the queries, but that they are expected to make changes to your application. So talking about CRUD, the queries would be responsible for the reading operations, while the mutations would be responsible for creates, updates, and deletes. And that's how a mutation looks like on a GraphQL request. So instead of calling it query, like there at the first line, you just call a mutation, and then you put the mutation name that you want to query, which here is create media. I'm trying to create a media item. And then you pass the input parameters to that. In this example, I'm passing a URL of a YouTube video. There is the client mutation ID too, which is mandatory to go along with every request, but if you're using Relay on the client applications I'm going to show later, you don't need to worry about that because it's going to do it for you. And then at the end, you put the desired output. Here I'm saying that after I created this media, I want the backend to return for me a media item with just the ID attribute. And then how to do that on Rails. So there is also a method to define a mutation for you, and then you just pass the input fields, the return fields, and then a resolve method. So if you already have an application with lots of models and that are expected that you're going to have CRUD endpoints for all of them and they all look the same, this can be a pretty boring task to define the mutations for all of them. In order to do that, we implemented a library, which is not released as a gem yet, but that makes the job much easier. That we can, on a single call, create the mutations for all the three operations by just passing the name of the model, the parameters available for the creates operation, and the parameters available for the updates operation. And using all the power of Ruby meta programming. And this is it on the backend side. On the client side, we are using React.js for our application. And it's a library developed by Facebook, and it was open sourced recently. And it operates on the view layer of your application. So yeah, another JavaScript framework, there is one every day. Maybe after I started the talk, there is already 5 new ones or something. And it's really hard to keep up to date with all of them. But why we decided for this one and why is React different from others? It doesn't have controllers, directives, templates, global event listeners, nodes, or things that we see on many JavaScript frameworks. But something really number one to understand how React operates is by understanding that everything is a component. And how does it work? Back to our example. How would we do this using an MVC JavaScript framework normally? We would have like a library to take care of the controller operations with methods to add comments, to delete comments, to add tag, and etc. We would have another file with our HTML display for that component with all the information that we want to display. And at least we would also have a file to connect those two pieces, to guarantee that interactions that happen on the UI will trigger controller actions and actually make the requests to the backend. And on React, it looks a bit different. The whole thing is a component, like each screen or each part of your UI is a component, which is made of other components. So here, if we had the media component, it would be made of a tags component, which is also a component made of a tag component for each of the tags that are displayed. And then we have a comments component, which is a list of all the comments. We have a comments component for each of them. So it's always like using bricks to build the thing. By comparing those two approaches, we can see that the main difference is that on most MVC frameworks, we have a concerns separation. So you have parts of your code that is responsible for the models, parts of this code that is responsible for the controller, parts of the code that is responsible for other actions. And here we have a different approach, which is a components separation. And we have single components for each component, each part of your UI, which is completely responsible for everything that this part of the UI does for you. So it is responsible to tell how it should be displayed. It is responsible to tell which data it needs from the backend, and it's responsible to take care of all the interactions that can happen on the UI. So the main advantages of this approach is that this way components are easily testable, composable, as you can mix them to build another one, reusable and maintainable. On our team, we noticed a huge difference, especially on the testability and on the maintainability, because you can have people from your team focused on working on some specific components and deliver that to other developer that can build that on your interface. So it's worked really well for us. And back to our interface, I took here a minimalist example of how a component would look like for our interface. So here we have a single tag from our tags list, and then every React component extends from a base component class, and this render method is supposed to be mandatory for all the components. This is the method that's going to tell what is going to be rendered on your HTML, as the name must say. I won't enter in details now about the other parts of the components because we are going to see each of them separately now. So we can see here that on this return function, on the render method, this file looks a bit confusing because we have HTML mixed with JavaScript. So of course, this is not a valid JavaScript. So what is it? This is what they call JSX. So it's a markup language similar to HTML, but that tries to combine the ease of using templates. So you don't need to call methods to create an element, to set an attribute, to send some nodes to another part of your DOM. So it has this facility, but you still have all the power of JavaScript to define the other methods to control the states and the interactions between those elements. And in order to translate this JSX code to JavaScript, there is a preprocessor provided by React itself that makes this compilation for you. So this is really easy to use. Another thing is about performance. So usually when implementing client-side apps, there are some things that we need to keep in mind in order to have our application with a good performance. One thing is to avoid costly DOM operations, minimize the DOM access as much as possible, and update them offline before inserting on the DOM, and etc. So these are things that we as devs usually need to be concerned about. So on React, this is a bit different because it rebuilds everything on every change. So you don't deal with things like, oh, I received this response from the server, I want to hide this element here, so I will find the element on the DOM and call the hide method of that. It doesn't work this way. You need to keep in mind that everything that you just implement your code once, your component code once, and then you can have the different aspects of your components based on different states. So, as I showed the code here, it will be a bit clearer. It seems costly to rebuild everything at every operation at the first glance, but it's not because it's not a real DOM. It's something that React calls a virtual DOM. So it batches all the operations and just apply them at once to the browser. And you don't need to worry about which elements should be updated. You just change data on your states, or the backend returns some different data for you, and React is going to calculate which elements should be updated, and it's going to batch these operations and apply them at once. So you don't need to be worried about that. The rule number 3 is that there is a single data source. All data that you are supposed to display on your components will be available on something that's called props. So here we have an example of how to add the tag component to another component. It's like an HTML tag with a tag attribute, and I'm passing a tag object for that. Every attribute that I called from here will be available on the component itself as a prop. So here, there on that blue line, we have a tag that was passed from the parent component to that. And props are supposed to be immutable. So this is the data that comes from the backend. You should not change it. And if you want to make changes to your data on your component, you should do it on a state. So states are supposed to be mutable. So for example here, on this tag component, after I delete a tag, I change my state to deleted, and instead of the whole HTML code for that tag that was just removed, I just show a label saying that it was deleted, just to be clear. So you can see here that the difference is that after the handle delete method there, I didn't need to find the tag and hide it. I just changed the states, and here on my render method, I say that when the state is deleted, I should not display the tag. Instead, I should display a label saying that it was removed. So it's a completely different way to think how to build JavaScript applications. And you also don't need to worry about events, like, oh, it is loaded, it is not loaded. You don't need to worry about that. React will make available for you some callback methods from what it calls the life cycle of a component. So there are a few, I didn't list them here, but there is like callbacks to say that the component will mount, the component did mount, it will unmount. So you don't need to worry about all those crazy asynchronous JavaScript bugs that we see every day. And then this is React for HTML applications on the browser, mainly. There is a branch of React which is meant for mobile applications that's called React Native. And the main difference of React Native to other libraries like Ionic that allow you to write code in HTML and JavaScript and make a mobile app out of that is that React Native, as the name says, will compile it as a native app for you. So it's not a web view app with JavaScript code that is running there for the user. It will compile as a native app. So it's a library that will convert code written on that JSX syntax to iOS Cocoa or to Android UI. And since it is native code, the performance is like a native app, and you can have all the power of writing the code in JavaScript and reuse all the components that you have for your web application. You can reuse on the native application, so this is pretty cool. And you don't need to write code in Objective-C or Java, which is like good. So you can have React components the same, and if you use the React.js compiler, it will compile a web app for you, and if you use the React Native approach, it can compile as an Android or iOS app using almost the same code. Almost, because for some interactions between your application and the mobile phone, we need to use some React Native modules. For things like putting your app on the share menu, which is something that we needed to implement and that is available as a module. So it's something like pretty early, also React Native, so some modules are not really ready. But there is a huge documentation if you want to write your own. It's pretty easy. I implemented this one like one day, and the API is really good for you to implement new modules. So you have one code that, I said in the beginning that we have this generator for Node.js applications that we use to create our client apps, and it's something that we can use this almost the same code and compile it as a web app, as a browser extension, or as a native app. So, for example, here, in order to be more clearer, our generator generates by default a web application that receives a URL as a parameter, because on our case, on our two applications, the main goal is to translate social media or to fact check social media. So we are always dealing with URLs as input. So when you compile your application as a web application, you are supposed to pass the URL as a URL parameter on the address. If you are using it as a Chrome extension, it's going to read the URL from either the current location if you call the extension from the toolbar, or from a link if you right-click a link and invoke the extension using the context menu. And if it is a native Android app, you can share some URL that you're visiting by calling the application from the share menu of your phone, and then it is going to open the app with that URL available for you. That's how we do it. But in order to make this connection between all the data we have on the backend, exposed as a GraphQL layer, and all those client apps written in React and React Native, that's what Relay does. So it's literally to make this connection between GraphQL and React. And it's also part of the React suite, let's say. So this is how things work. We have the components of the React.js app. It makes GraphQL queries to the server, and the server responds with data that's going to refresh a local relay store, which is like a local cache. So if the same data is asked again, it's not going to reach the server again, it's going to read from the local cache. And then the relay store passes this data as props to the components. And also, when you make operations on your components that should trigger mutations, it uses also optimistic updates. So if I'm creating a media item, it's going to first save that new item on the relay store and then make the request to the server. So for the user, it looks like the action was almost like it happened at the same time, but it is because you are using an optimistic approach. And so in order to be even more clear, this is how things work. The React components passes a GraphQL query to Relay, which is going to reach the server if needed. And then the server responds to Relay, which is going to update the local store and then pass the data to the component. So it works as a middleware to decide which requests should go to the server and which should not. So you can have a very good performance with that thing. Back to our components, how would we make this components query all data it needs to be handled using Relay? So here on the right, on the bottom, we have the media component. So it needs to return a Relay container, and a Relay container is supposed to contain two things: a route, which says which endpoints on the backend it should query from, and a component which is basically to which component I should send the data that I'm going to retrieve from the server. And after that, I write my query. Here I'm querying the title and embed the user of the media. And then after this request is made, I just render all of them on my HTML component. So you basically needed those three pieces in order to have a React components query or your data from the GraphQL. You need a container, you need a route, and you need a component. But as we can see, we have all the logic handled by the component itself. It knows which data it needs from the backend. It asks for that data, and it handles the HTML structure with that data too. So, as I said, only new data is requested. It's going to hit the local cache first. And it also contains a JSON file, which is exported from the backend using a rig task with your schema. So if some invalid request is made, it is first validated against that JSON schema that you have on your application. So if it's requesting some endpoint that doesn't exist or some field that's not available, then it's going to throw an error right away without needing to make this request to the server and let the server return an error message. So it does it right away from the client because you have this schema locally. And again, mutations, how to do then on the client side. It's basically a composition of 4 different methods. One is the get mutation, where you just define the name of the mutation that you are calling. And then something called get fat query. Well, I personally think that the name of those methods in Relay are not intuitive at all. But after you read the documentation, you can understand them really well. So on the get fat query, you're just saying which data I want the backend to return for me after I send this mutation. In that case, after I send this mutation, which is to create a new tag, I want just to return that tag that was created and also an updated list of tags from the media item so I can update it on my local store. On the get variables methods, I say this is the parameters that I'm really sending to the backend. So in order to create a tag in this example here, I needed to send the tag value itself and also the media ID of the item that I'm tagging. And most confusing one is the get configs method, where you basically say what to do with your local relay store after this mutation runs. So basically here I'm saying that this is a range add operation, which is basically going to add this new item that I'm creating to a collection, which on this case is the tags list of the media item. So that type here, which is range adds, there are 3 or 4 of them, which basically means different operations that need to be done on the relay store after the mutation runs. And now back to our React components. how we call a mutation. So you basically instantiate it, and you pass as attributes all the values that you want to send to the backend, and that on the mutation file on the JavaScript side is defined on the get variables method. And yeah, and that's it. Thank you.